My name is Videsh Ray. I'm in USACO Gold. I'm a sophomore in high school, and today's going to be a video on a simulation problem in Bronze. So in this problem, it's listed as a hard problem on USACO Guide, but it's actually pretty easy when you understand like the solution behind it. Um, and yeah, so we can get into it. So the problem is that Farmer John has a subscription to a magazine for his cows, so that they can read. But the latest issue of the magazine has an inappropriate article on how to cook the perfect steak, which Farmer John would not want his cows to see. Um, yeah, and then FJ takes all the text from the magazine to make one string. So he just takes all this text and puts it together into one string. And then he wants to remove the occurrences of a certain substring with a length that's like up to 100, so he can censor inappropriate content. So think of S, the string S, as the entire magazine, and then a substring T as like maybe a word that he doesn't want to show up, or the article that he doesn't want to show up, which has the inappropriate content. And then Farmer John finds the basically to censor it, he finds the first occurrence of T and deletes it, and he does it again and again until it's not there anymore. Um yeah. So the input format is that the first line will have S, which is the article, like the full article, and then the second line will have T, which is censored the censor, like what he wants to censor. So S is like the full magazine, T is the article, like that he wants to censor. Okay, so in this sample input, you have what, so W H A T and then THEMOMOFUN. That's S, so this is the entire magazine. What he wants to censor in the word of the string S is moo. So if you just do what he does, right? So you find the first occurrence of the censor like word, which you find it right here, um, right here, and he has to delete it. So you just kind of delete it. Um, Now what happens is you have, I think I deleted too much. Yeah, okay. Now what happens is you have this left, and obviously, like once you delete the censored word, like now the rest of the text comes together. So now the text would look like this. So once you recombine it, and like the split was right there, that was the split, and like now it's come together. But now you have another occurrence of the word, of the censored word. So now I have to erase that too. Um, yeah. Now you erase that, and then finally, now there's no more uh occurrences of the censored word. So you can output that, and like this matches up with the sample output. What the fun? And yeah, so that was like an analysis of the sample input. Now, when you're doing solving the problem, it can be tough to, so for example, when we had uh, our sample input, when we deleted the first instance of moo, another one came up by, because like we deleted this, but then there was an O here and an MO over here. So that made it so that like another instance of the censor word came up. So it can be tough to deal with um, like deleting and then putting it back together. So we have to go with a different approach. Like we can't directly do what we did when we were analyzing our sample input. So I would encourage you to think about it for a second. Um, and if you have, that's great. But yeah. Anyway, so just think about it for a second, and I'll go into the solution. So the solution basically is that to censor it, you're going to continuously add characters one by one to your final result. So like over here, this is our final result, right? And we're gonna build it little by little, letter by letter, and keep going. And we're gonna continuously be checking, like whenever we add a new letter, we're gonna check if we have the censor word inside it. And if we do, then we'll delete it, and otherwise we'll continue. If if the censor word is there, we'll delete it and then continue. So yeah, that's all the solution is. So it's pretty easy. And I can show you how to implement it now. So I already have like a file here. A folder. I made a folder and um yeah, and I'll use C++. Yeah. Okay. So I mean, this is just like including the like most of the C++ library using namespace std so that you don't have to write std each time. Just define like instead of writing long, I just want to write ll. So that's that. This is fast input output, and it's my main like body of the code. Okay. Now, so the input format is going to be they'll give you two words, right? S and T. So the magazine and like what the censored part, like what they want you to censor. Um, and what we can do is this. Okay, so we'll have our string for our answer, right? Like our final result, and we're going to loop through S, which is the original like magazine, the uncensored. Okay, and then what we'll do is we'll do answer plus equals s of I. So whatever the current character is that s is at, like inside of s, what character we're at, we'll add that to answer. Okay, and then now we're gonna use some C++ functions, some built-in functions, um, to check. Okay, so you could do this manually as well. But like a simple way to do it manually would be to use like a string and add to the string to use it to check and stuff. But the thing is that if you do that, like adding to strings can be like pretty like taxing on the time complexity. So you would actually like time out for some test cases. Like I've done this before once and I did it manually. I tried to, so here what we would do is we would use the substring function, but when I did it manually, it timed out because of the way I was doing it. Um, Now it can be done like without timing out. If you'd have to use like a vector of characters for that, probably, I would think, and then like do something with that. Except it would be like you can do that. It's just much simpler to use the functions. So yeah, so I'll just use the functions for this. Now, the first step is to check if you can actually censor a word or not. So the length of our answer has to be greater than or equal to the length of the censor word, which is t. Um, because otherwise, then there's nothing to be censored. So basically, if answer dot size is greater than or equal to t dot size, then we might be able to censor something. If this is not true, that means that we can't censor anything because if the censor word is bigger than what we have in our answer in our final like string so far, then the censor word won't even be able to fit. So that's why we do this check first, this if statement, and then we do um, if answer dot substring. And now where do we substring? So since we're checking, like we add characters and we check if the last few characters are equal to the censor word. So that means we have to do answer.size minus t.size. So, okay. Okay, basically what we do here is answer.size is just the size of our final like string so far. And we do minus t.size. T.size is going to give us the size of the censor word. Um, because we want to check if the last few letters are equal to the censor word. So let's say our censor word is moo, like it was in the sample input, and let's use yeah, let's just do this with the sample input, like to analyze it. So how this would work is that let's say we're over here, okay? Let's say so far we've gotten to this step, and we just added moo. We just added the O over here, which completes the censor word over here, um, to our final string, okay? So obviously the length so far, so we've gotten to over here so far, okay? So the length so far is obviously greater than moo, so we go into that. Now what we want to do is, so the size of answer so far is going to be, this is 4, 7, 8, 9, and this is like 12, I guess, right? Yeah, 12. So the length is 12, the size of this, and the size of this is 3. So you want to do this, so this 12 minus 3 would take you to 9, position 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So that covers those 9 things. Okay? Now what happens is the substring is going to start from that ninth position. So like after the ninth position, like over here. Okay? So answer.size minus t.size gave us 9. So if we do substring on 9 for this string, it would return these 3 letters, moo. Basically when you do substring, everything after that like position will be um what is returned from the substring function. So now we see that this moo is equal to moo, right? Like moo is moo. So that's what we get here. So when the substring function returns moo, we see that it's equal to t, which is moo, and then we would have to censor it. So that's how that works. Um, yeah. So then like what we would do is like before adding the rest of it, we would delete that, and then this O would get shifted over here. Oh, I think I have cap loss. Yeah, okay. So that O would get shifted over here now, like we add on the O. And then once again, we would do the substring thing. Um, Now this time I think it's uh that's 6 and that's 4, so it's length 10 now. So I'll do it one more time to show the point, like to like show how that it really works. So that's length 10. This is length 3. So we go to 10 minus 7, right? I mean 10 minus 3 is 7. So 1, 2, 3, 4, 5, 6, 7. And yeah, so after that, everything after that is the um what we check for. So we see that again, like this is equal to, that's moo, and that's the censor word, so we have to delete that. Then this f would get shifted over here, and like for the rest of the steps, we would never match, because like all the moves are gone. So yeah, that's how that works, and that's like also like the how you use the substring function. Now after you do that, this is how we delete the censor word. So we use the C++ function called resize. So what we do is answer dot resize, and we use the exact same uh position actually, except it operates like slightly differently. Um, but this is still like the correct position. So now what happens is, so let's say we have what the mo- 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 okay, so like we had earlier. Then okay, so let's say we're over here, right? So we haven't seen the rest of that yet, but we're over here at what the mo moo, okay? So here we resize it that position, right? So earlier, like we figured out like this was like 12, this was 3, so position 9 took us here. So when we do resize at this position, what happens is everything from the first position to the position we give the function, the parameter that we pass into it, everything from there is preserved. Um, but the rest of it is basically kind of like ignored, and it'll be like overwritten like later in like thing. Like basically, this is essentially it's ignored now. It's like basically deleted. It's gone. And we're just left with this. So how it works is when we have it'll preserve everything from here to there, and it'll kind of close in the right bound and kind of just push it in, except it's not really pushing it in, just kind of like ignores it and it gets deleted almost. Um, Pretty much it gets deleted, and then we just left with this. So then when we take that O and put it here, again, when we pass in this value, like that's it, like this position, so then all of this will get preserved and this essentially gets deleted. And that's how we use our resize function to delete the censor word. And that's really all we have to do. And at the end, we just output answer and with a new line. Um, and yeah, that's all it is. It's actually pretty short if you use functions. If you try to um, if you try to do it manually, it would take like a little bit more implementation, but it'd still be not that hard. And yeah, this is just because like this problem requires file input output. So let's give it sample input. Let's see what we get as our output. 1 second here. So then, yeah, okay, here's our output. So what the fun, and yeah, that's correct. So we can just submit this now. Um, okay, and we're already in that file. Okay, yeah. So the C++ file, submit solution. Oh, we have to log in. And so yeah, you could also like do this manually. The instead of using functions, it would just be like don't you wouldn't want to use like a string. Like the brute force way to like just like convert it instead of using functions and using the thing would be to use like strings to add on characters and check and stuff. But that's like taxing on like the code on the program like complexity wise, so it would take a lot more time. So you'd want to use like a vector of characters and kind of deal with it that way. It's just a lot simpler to use the functions here. And you'll see like it was barely 20 codes like lines of code. So yeah. So it's a pretty simple problem. You just have to kind of understand like the logic here. And yeah. So yeah, that was it. Thank you for watching that. Yeah. And I'll be posting like more problems on different topics and stuff in the future. Thank you. Bye.